The rate of growth of micropopulation is given by m prime of t. This equals 48t e raised to the power of 3t. And we have to calculate the total accumulated growth during the first 2 days. So we say that the accumulated growth during the first 8 days, this is basically the integral of m prime of t dt, and the limit is from 0 to 2. Since we have to calculate during the first 2 days, we put the lower limit as 0 and the upper limit equals 2. So let's calculate this. I'm going to substitute m prime of t as given in this equation. So it is 0 to 2, m prime of t is 48t e raised to the power of 3t. So I put 48t e raised to the power of 3t inside the integral. Now let's see how to evaluate this integral. First, I factor the constant 48 out of the integral. So we can write down this as 40 times of 0 to 2 t times e raised to the power of 3t dt. And now we have to evaluate this definite integral, that is from 0 to 2 t e power 3t. So we will see how to evaluate this integral. Here we have a product of two different functions. That is, this is t e power 3t. This is an algebraic function and this is an exponential function. And when we have to integrate a product of two different functions, we have to apply the integration by parts method. In this method, we follow a rule called ILATE, and each letter stands for function. I stands for inverse, L is for logarithmic, A is for algebraic, T for trigonometry, and E for exponential. So first we have to choose U according to this ILATE rule. We first look at the rule in this order, that is from left to right. When you see the rule from left to right, inverse comes first. So we have to look inside our function, that is inside the integral, and we have to look out for any inverse function. We don't have any inverse function. We then move on to the next function, that is logarithmic function. And do we have a logarithmic function? We don't have logarithmic function. So then we move on to the next function, which is algebraic. So here we have algebraic function, that is t. So what we do here is that is t e raised to the power of 3t. We consider this t as u. This is according to the ILATE rule. And then the rest of the terms we consider as dv. So now we have chosen u as t and dv as e raised to the power of 3t according to the ILATE rule. And we will also utilize the integration by parts formula. So first let's figure out dv, u and dv. So we have u equals t and dv equals e raised to the power of 3t dt. Now this side we have to differentiate. So I take the differential, du equals dt, and this side we have to integrate. So integration of dv is v, and integration of e power 3t is e raised to the power of 3t, and then we have to divide by the derivative of 3t. The derivative of 3t is 3. So it's basically e raised to the power of 3t divided by 3. We will not have to put the integration constant, as this is a definite integral. Now let's apply the formula. So first let me write down this. So we have 48 times integral from 0 to 2 t times e raised to the power of 3t dt. So we have decided that this is u, this t is u, and then e raised to the power of 3t is dv. So this is in the form of the integration by parts formula, that is u dv, and this equals, according to the formula, it is uv minus integral v du. So therefore we can see that this integral is equal to, we have the 48 in front, so I put this 48 in front, and then I have to put uv. So let me put the uv. U is t and v is e raised to the power of 3t by 3. So I'm going to plug it here. So you have t times e raised to the power of 3t divided by 3. And since this is a definite integral, we have to apply the limits to this expression, that is 0 to 2 minus, and we apply the formula, that is integral. So we once again put the limits 0 to 2 v du. V is e raised to the power of 3t divided by 3, and du is dt. So we put the dt here. So then we have to evaluate this expression. We have to apply the limits, evaluate this expression, and then we have to integrate and apply the limits. So let's do that. So we will have 48 times. This is when we apply the upper limit, we get, that is, we apply upper limit to the t. So this will become 2 times of e raised to the power of 3 times of 2. That is, we replace t by 2, so therefore it becomes 3 times 2 is 6. So it is e raised to the power of 6 divided by 3 minus, we now apply the lower limit. So when we apply the lower limit in place of t, this becomes 0 times e raised to the power of 3 times of 0 is 0. So I can just put this as 0. Then this is divided by 3. So we are done with evaluating the expression. Now we have to evaluate this integral and then apply the upper limit and lower limit. So here we have e raised to the power of 3t. We know that integral of e raised to the power of 3t is e raised to the power of 3t divided by 3. But since we already have one more 3, this 3 and this 3 will get multiplied, and we can put this as divided by 9. And this has to be evaluated from 0 to 2. Let me put a bracket over here so that we will not make mistakes. So now let's simplify. This is 48 times. This becomes 2 times of e raised to the power of 6 divided by 3. And this is 0 because 0 times a quantity is 0. So we simply ignore that. Now let's apply the upper limit and lower limit of this expression. We have to apply this as well as this. So first I put this negative and then put a bracket. So in place of t, I have to put 2. So once again, this will become e raised to the power of 3 times of 2, which is 6. So e raised to the power of 6 divided by 9 minus, now we have to apply the lower limit, that is 0. So when we apply 0, it becomes 3 times of 0, that is e raised to the power of 3 times of 0. And this is nothing but e raised to the power of 0. We know that e raised to the power of 0 is 1. So it's basically 1 over 9. Now let's continue. We'll simplify this. So this becomes 48 times. This is 2e power 6 divided by 3. Now we open the bracket, we distribute this negative. So this becomes a negative e raised to the power of 6 divided by 9. And then this negative times negative will become positive. So it becomes 1 by 9. Now we can simplify this further. So I put this 48, and then the common denominator is 9. And so I have to multiply and divide this first term by 3. That is, I do like this. Then we will have a common denominator of 9. So then these two will get multiplied. That is, 3 times 2 is 6. We get e power 6 minus. Here we have the common denominator 9. So we write the numerator as it is. Plus this is also common denominator. We then put 1. So now we have the like term 6 e power 6 minus e power 6. And this is 5 e power 6. So I write down 48 times 5 e power 6 plus 1 divided by 9. Now we see that we have a common denominator of 3 in 48 as plus 9. So this 48 equals 16 times 3, and this 9 equals 3 times 3. And this means we can cancel the common factor in both the terms. We have a common factor 3 here, and also we have a common factor 3 here. So finally we are left with the value, that is 16 over 3, times of 5 e power 6 plus 1. So this is the total accumulated growth of the microbe in the first 2 days. This is in terms of expression, and we can also plug this into the calculator. And when we do that, we approximately get 10,763. So this is in terms of microbes. So we can say that the total accumulated growth equals, this is total accumulated growth of microbes in the first 2 days. And this approximately 10,763 microbes.